In this video, we're going to take our FastAPI application and we're going to add a relational database behind the application to store and retrieve data from. And in this video, we're going to see how to use the 𝗙𝗂𝗧𝗧𝗧 package, and we're going to use that for the models and for the data layer of the application. So we're going to remove the dummy data from previous videos, and we're going to add this relational database in a FastAPI application. And in the next video, we'll also add the 𝗬𝗵𝗽 package to manage our database migrations. So that's coming up. If you're enjoying this content, give the video a thumbs up and subscribe to the channel if you've not already done so. And let's dive in. So we're going to start by creating a database in this project, and we're going to use this package called 𝗙𝗂𝗧𝗧𝗧𝗧 in order to interact with the database from our FastAPI application. Now, if you're wondering what 𝗙𝗂𝗧𝗧𝗧𝗧 is, it's based on Python type annotations and it's powered by Pydantic and 𝗙𝗂𝗧𝗓𝗲. And 𝗙𝗂𝗧𝗧𝗧𝗧 is designed to be intuitive, easy to use, highly compatible and robust. Now if we look at what we had in our application, so far we were hard coding these bands, and there were some previous videos and a playlist on this topic. You can check that out if you've not already done so, or you can just follow along with this video if you want to learn how to integrate FastAPI with 𝗙𝗂𝗧𝗧𝗧𝗧 and a relational database. Now in the previous videos we had a schemas.py file, as you can see here. And the purpose of these classes was to model the structure of the data that we were working with in our FastAPI application. What we're going to do in this video is convert these models from Pydantic models to 𝗙𝗂𝗧Model classes. Now we've done a previous video on 𝗙𝗂𝗧Model if you want to check that out, but basically a 𝗙𝗂𝗧Model class is a subclass of the Pydantic base model, and so all of the functionality that we get with Pydantic models is available on the 𝗙𝗂𝗧Model classes as well. So let's start by renaming this file from schemas.py to models.py. And what we're going to do at the top of this file is we're going to import the 𝗙𝗂𝗧Model class, and we're going to create subclasses of that instead of the base model. And by doing that, we'll get that database functionality later in the video. Before we do any of that, of course, we need to install 𝗙𝗂𝗧Model. I have a Python virtual environment activated, and we're going to run the pip install 𝗙𝗂𝗧Model command. And that's going to install that package into this environment. Once we've installed that, we can go to the top of the file here, and from 𝗙𝗂𝗧Model, we're going to import two things. First of all, the 𝗙𝗂𝗧Model base class, and we're also going to import the field class as well. Now, once we've imported these, we're going to go down to the actual model classes. And because we're going to work with a database, we're going to change things up a little bit within these classes. So first of all, I'm going to change the name of the album class to album base. And instead of Pydantic's base model, it's going to inherit from the 𝗙𝗂𝗧Model base class. So for an album, these are the base attributes, and that's the title and the release date of the album. If we go back to main.py, here's the schema that we've been working with in this series. The albums are represented here in a list, and you can see they have a title and a release date. Now we're adding a database, and that's going to add an ID primary key. So that's why we're changing that to an album base, and then we're going to create a class called album, and that's going to inherit from that album base class. And we're going to add a new field for the ID here. So that's going to be of type integer, and that's going to be equal to a field, and that's what we imported from 𝗙𝗂𝗧Model. And we're going to give it a default of none, and we're going to say primary key equals true here, and that's going to make that the primary key for the album table. Now, because this is going to be a database table, in 𝗙𝗂𝗧Model we can add a keyword argument to this class, and that's table equals true. And basically any 𝗙𝗂𝗧Model subclass that has table equals true is going to be represented as a database table. So just to re-explain what's happening here, we have a base class containing a title and a release date, and that inherits from the 𝗙𝗂𝗧Model class, and then we define a subclass of that called album, and that will inherit from our base class, and it adds that table equals true, which tells 𝗙𝗂𝗧Model this should be a database table, and it contains the ID field as well as the inherited fields from the base class above. Now let's go down and do the same with the band models. So we have a base class here, and that's going to inherit from 𝗙𝗂𝗧Model. And one thing we're going to do is move the albums from the base class down to the band create class. So let's do that now. We're going to paste this in and change it in a second. The band create class should inherit from band base. And this is the schema of a post request that's sent to FastAPI in order to create a new band with optionally some albums in the database. So let's change the type hint for the albums that are going to be sent to the backend. This is either going to be a list of the album base class. So if we scroll up here, we have album base, and that contains a title and the release date for the album. And note that it doesn't contain an ID because that's set by the database on creation. So when we create a band, we can optionally pass a list of these album base instances. And because that's optional, we will use the union type here, and we can say that that will be optionally none. So we don't need to send albums when we create a new band. And we're going to set the default value to none for this particular field. And the last thing is the band with ID class. We're going to create a table in the database called band, so I'm going to change the name of that to band, and we're going to pass table equals true as a keyword argument. So that's going to inherit all of the fields in the band base, and it's going to add the ID to that. And again, we're going to set that to a SQL model field, and we're going to set the default to none and primary key to true. Now, one other thing we need to do is set up relationships between these models. So I'm going to go to the top here, and from SQL model, we're going to import a relationship object. Now, the reason for this is because we're now using database schemas, and we have a relationship between a band and an album. A band has albums, and an album belongs to a particular band. So an album has a foreign key to the band table, and we need to represent that in the SQL model schema. So in the base class here, what we're going to do is add a band ID field, and that's going to be of type integer. So when we have an album, we're going to link that to a band via the integer foreign key. And because this is a foreign key, we're going to use the field object in SQL model. And we're going to pass the foreign key keyword argument here, and we're going to set it to a string that references where the foreign key is going to go to. And that's going to be on the band model, and it's going to be the ID field on that model. So we've added a band ID to the SQL model base class for the album table. And when we have a table equals true instance below for the album, it's going to inherit this and create the column in the database. Now, this line of code here is how we add the column in the album table that links it to the band. But what we can also do is add a relationship on the main class here, and that's the album class. And by adding this relationship, we're going to easily be able to go from an album instance to the parent band to which that album is linked to. Now, we're going to do that on a field here called band, and that's going to be an instance of the band model. We're going to set that to that relationship object that we imported from SQL model, and we're going to add a back populates keyword argument and set that to albums. Now, because band is defined below here, right at the bottom of the file, we're going to reference this using a string, and that's going to avoid those errors. And what that means is that if we have an album, we can access the .band property to go from that album to the related band instance. And we can do this in reverse as well. So if we go down to the bottom here, we have the band. If we wanted to fetch all of the albums that are associated with that band, what we can do here is set up a property called albums. And that's going to be a list of these album instances. And we set that to a relationship. And again, we're going to pass back populates into that. And we're going to reference the band on the album. So this band property here, it references what we have on the album model. The property with the relationship is called band, and that's what we're back populating here. And the same in reverse, we're back populating albums, and that's the name of this property on the band model. So we've restructured the schema.py file into this models.py file that contains database models. What we're going to do now before we actually create the database is go back to main.py, and at the top we need to fix some of these imports. So we changed schemas to models, and we changed band with ID to just band because it's now the name of a database table. And we're also going to import the album model as well. Now for now, what we're going to do is comment all of these endpoints that we created before out, and we're going to fix them up one by one later in the video. Let's now go to the left-hand side, and we're going to create a database.py file. And this file is going to define and store our database connection information. Now at the top, I'm going to bring a couple of imports from SQL model. We're going to import the create engine function, and we're also going to import the SQL model instance and the session object as well. Now let's define a database URL, and we're going to set this to a SQLite or SQLite URL. And I'm not sure exactly how you pronounce this. Someone said one thing, someone said another. You can leave a comment if you know how that's supposed to be pronounced. But what we're going to do is define a file here called database.SQLite. And SQLite is a file-based database, and that reduces the complexity a bit because we don't need to install any external systems or processes like PostgreSQL. We can just create a file on the file system, and that's going to be our database for this project. Once we've got the URL, we're going to create the engine using that create engine function, and we're going to pass the database URL into that, and I'm going to pass echo equals true. And finally, at the bottom of this file, let's define a function called initdb. And we're going to call a function on the SQL model.metadata object. And that's the create all function, and we pass the engine into that. Now what this SQL model.metadata is going to do is it's going to look at all of the models that have that table equals true parameter. And these are the models that should represent database tables. And it's going to create those tables in the database using this create all function. Now we can test this initdb function in main.py. And to do that, we're going to create what's called a lifespan event in FastAPI. So what's a lifespan event? Let's go to the documentation. If you need to define logic that should be executed before the application starts up, or define logic that should be executed when the app's shutting down, you could use these lifespan events for both of these use cases. So let's go down and we're going to look at the code here. And what we need to import is something called the async context manager from Python's standard libraries context_lib module. So let's import that at the top. And if we go back to the documentation, we're going to define a function called lifespan. And that's going to take the FastAPI application as a parameter, and it's going to be decorated with that async context manager. So let's copy these two lines of code and go back to the application. I'm going to paste them in here. And what we're going to do is import this initDB function that we defined in the DB module. And we're going to call that in this lifespan function here. So let's do that now. We're going to import from DB. Let's import the initDB function. So let's call that within the lifespan event, and then we can use the yield keyword in Python. And after we do that, the FastAPI application will start up and our database tables will be created by this function. The last thing to do is pass the lifespan function into the FastAPI object here, and we can do that using the lifespan keyword argument. So now when we start this FastAPI application, we expect to see the database created, and we're going to create the tables in that database. So let's go to the terminal here, and we're going to use 𝗬𝗏𝗀 to run the application. And our app is in main.py, so we're going to reference main, and the name of the app object is app. So let's copy that, and we're going to paste that in here and run this command. And you can see on the terminal when we started that, a create table command has been executed against the database. And on the left-hand side, we now have a db.sqlite file. And this file is going to be our database for now. If you want to know how to set up FastAPI with MySQL or Postgres, and that could be on Docker containers as well, let me know in the comments. What we're going to do now is go back to the db.py file, and just below the initDB function, we're going to define a new function. And this one's going to be called getSession. Now what we want to do here is return a session that can be used by our FastAPI handler functions. So we've commented out all of these handler functions, and each one of these before was operating with this hard-coded data that we had on line 17. We're now going to go to the database to fetch data and also to add new data to the database. And so in order to do that, every one of our functions is going to need a database session. So this function that we're going to create is going to be a FastAPI dependency that we're going to inject into those handler functions. So at the top of this file, we're going to import from SQLModel the session object. In fact, we've already done that. And what that means is that we can create the session here using a context manager. So with the session, and we pass the engine into that object, and we can call the returned value session here. What we're going to do within this dependency is just yield that session. Now we want to inject this dependency into our handler functions. So let's go back to main.py. And at the top of the file, we've already imported initDB from that module. So we're going to also import the getSession function. And from FastAPI at the top, we're going to import an object called depends. So now that the setup is complete, we're going to go down and look at these handler functions that we've commented out. And we're going to bring these back one at a time in this video. Now what I'm going to start by doing is looking at the post endpoint here at the bottom. And this is an endpoint to create a new band in the database. So let's uncomment this now. And immediately we can see some of the changes that we need to make here. So bandwidth ID, that was changed to the band model. When we create a new band, our post request body is going to expect a schema that conforms to the band create model. And then after we create the new band in the database, we want to return that band model that actually represents a record in that database table. Now we can get rid of this logic here. We don't want to append this band to a list in memory. And we can remove this bandwidth ID line, and the ID that's being defined on the line above, that's now going to come from the database. So we can actually remove all of this. What we're going to do is create a band from the data that's been posted in the request body. So let's create a variable called band, and we're going to instantiate a band here, and we're going to define each of the fields on that object. So the band takes a name, and that's going to be equal to the band data that we have above. That should contain a name field. And if we go back to models.py and we look at the band create schema, that inherits from this base that contains a name and also a genre. So let's copy that and go back to main.py. When we instantiate the band, we're also going to pass in the genre here, and that's going to be from the band data. And again, it's the genre field in that post data. Now what we want to do is add this new band to the session, but we need to actually get access to the session within this FastAPI handler function. So let's inject that dependency now, and I'm going to start by restructuring this a little bit so we can see this. So after the band data, we're going to create the session, and that's going to be of type session, which we need to import at the top. So let's go to the top, and from SQLModel, we can import session here. Let's go back down to the function. And what we're going to inject here is using the depends function, the get session function that's in the database module. So you can use these FastAPI dependencies to inject certain objects into your handler functions. We now have a session, and what we can do is add the new band that we have above to that session using the session.add method. And then at the bottom, we can call session.commit in order to actually make that change in the database. And before we return the band, we can call session.refresh and pass that band in order to refresh that data from the database. So an example of why you do that is that when you create the band here, it doesn't have a primary key, that's the ID. That will only be created after you commit that to the database table. And then once you've done that, you can refresh the band object to get back all of its data, including that primary key. Now, the reason that we've got these lines in between the session.add and session.commit functions is that when we create the band, if we look at the schema for band create, and we can do that in models.py, this might also contain a list of albums for that band. So when we send the post request containing the band data, we might also have a key there called albums that is a list of these album instances. So we need to handle that now in main.py. So after we create the band, what we're going to do is check whether the posted data, and that's the band data, contains a property called albums. So let's do that now. If band data.albums is defined, what we're going to do is loop over each one of them. So for album in band data.albums, we can create an album object for that. And what we can do is instantiate an album, and we can pass some properties in there, such as the title. That's going to be equal to album.title. And just to refresh our memory, let's go back to models.py. The album contains the title, the release date, and also the band ID. So let's go back here. Let's pass the release date in here. I'm going to set that equal to album.releaseDate. And finally, we can pass the band in as well. So we're going to do that using the band parameter. And we're going to move this to a new line so that we can see this clearly. We've set the properties for the album, and we're using the relationship to set the band equal to the band object that we have on line 60 above. And we can do that because of this relationship that we have in the album class. Once we've done that, it's very simple. We can go back to this file here, and for each album object, we want to add that to the session so that it's going to be saved to the database. So we can use the session.add function, and we're going to add the album object to that session. Now we can test this out by going to api.http, and what this is using is an extension for VS Code called REST Client, and that allows you to send requests to your application from VS Code directly. And here's an example request with the name and the genre of the band. If we send that request by hitting this button just above the post request, we get back the data on the right for that new band that's been added to the database. And you can see it's been given the ID from the database itself. And what I'm also going to do is send a request that includes another key called albums. And I'm going to set this to a list of data that conforms to that band create schema. So when we send a post request, the album should contain the title and the release date. Let's try this out by again hitting the send request button. And we're getting back this issue here that there's a field required, and that's the band ID field. Now I'm going to fix this by going back to the models.py file. And it's this band ID, we can set this to an integer or none. And the reason we might want this to be none is that when we send a post request with the album data, we're not going to specify the band ID as part of that request. So let's make this an optional field and go back to api.http. So let's send the request again. And this time we're getting back an internal server error. And the problem here, and well done if you've noticed this, if we go back to main.py, when I create the album instance, we are passing in the release date, but I've called that release data. So let's change that and fix that. And we can now save this, and let's try it one more time. If we go back to api.http, let's send this request, and this time we get back the data. Now let's move on. We're going to go back to the main.py file, and we're going to go up to this particular endpoint here that returns the band by its ID. So I'm going to uncomment these lines of code, and then we can start changing this function. Now first of all, this is going to return a band instance. And this line of code here is looking up a band in that list that's in memory. We're no longer going to use that. What we need to do as a parameter to this handler function is inject the session as we did down here. So I'm going to copy this line of code, and we're going to go back up to this function, and we're going to inject that session as a parameter. Once we've done that, what we can do is we can try and fetch the band from the database using the session.get function in SQLModel. That takes an entity as the first parameter, and then it takes the primary key lookup as the second parameter. Now this function takes a band ID as a parameter in the URL. That's a path parameter in FastAPI. So we're going to pass that ID into the session.get function. So basically we're looking up a band by the ID that's provided in the URL. We can then check if that band is none. So if we don't find a band using that ID, we're going to keep this code the same here. We're going to raise an HTTP exception with a status code of 404. Otherwise, if we do find the band, we're just going to return that to the client. So this function is very similar. We've just changed some of the types here, and we're now doing a database lookup to try and fetch that band from the database by its ID. And let's move on to the final function here. I'm going to uncomment this line of code here, or these lines of code, sorry, and we'll test both of these in a second. Now I'm going to start by changing what's being returned from this list endpoint. So this is the function that's going to fetch all of the bands from the database and return them as JSON data to the client. So that's going to return a list of bands. And again, we can get rid of the in-memory lookup. And again, we're going to go down to this other function, and we're going to copy the dependency for the session and bring that into the list function. Once we're in that function, we can fetch a band list. And to do that, we're going to use the session.exec function. And then we can use a selection from SQLModel to select all of the bands from the database using that select function. And then after we've executed that, we can fetch all results using the .all function. Now we need to import select at the top. This comes from SQLModel. So as well as the session, we'll import select, and we can go back down to the function. That gives us back a band list. And I think we can actually keep the rest of this the same, although we do need to uncomment the last line of code. What we actually have here is we have some if statements, and these are parameters that are coming into the function. So for example, the user might specify a query parameter for the genre or a search term Q here. So what's going on below is if we have those values set, we're doing some filtering of the band list that's coming back, this time from the database. So now that we've made these changes, let's finally test this out by going back to api.http. And if we scroll down here, we have a GET request. I'm going to remove the query parameter, and we're going to send a request, and that's a GET request to the /bands endpoint to fetch that list of bands. Let's test this out, and we can see we get back the list that contains a single band, and that's because we only have one band in the database. If I go up to the top here, and we send that post request again, we're going to get back a second band, and this time, when we send that GET request, we can see that there are two bands in the list. Now these bands have ID of 1 and 2, so if we wanted to fetch a band by its ID, and that's going to use the other handler function, we can add /2 to that. And when we send that request, we get back only the band with that ID. And if we send a request with an ID that doesn't exist in the database, let's send that, we get back the detail of band not found, and the response code is 404 not found. So what we've done in this video is we've refactored our models, or schemas, to now interact with the database using SQLModel. And we've created that SQLModel connection in the db.py file using the create engine function. And we also created a dependency that we are injecting into all of our FastAPI handler functions. And that allows them to get a session object from which they can then interact with the database. And finally, we're using that session in all of the handlers. And now we're fetching data directly from a database. And we're also creating new records in the database. So what we can do to end this video is just remove the hard-coded list of bands. We're no longer using that in this project. We are now working with a database, and that has a lot of advantages over a list that's in memory. If our application crashes, we're not going to lose all of the data that's been stored in the database. And it's just a better way to organize the data in our application. Now in the next video, we're going to add a 𝗬𝗵𝗽 to this project. And we're going to see how we can manage the database and manage any changes to our database models in the models.py file using a 𝗬𝗵𝗽 and migrations. So that's coming up soon. If you've enjoyed this video, give it a thumbs up and subscribe to the channel for much more FastAPI, Django and other content. Thanks again for watching, and we'll see you in the next video.